role of c in a sinusoidal function. Okay, the last letter we have to investigate is this c, this number that's being added or subtracted inside the function directly to or from the x. Notice that the b is not a part of it. The b has been factored out to the front of that little expression. What happens if we put this c number in? Well, once again, we'll do some investigating on the calculator. Take a look at this first example here. Y equals sine of x minus pi over 2. So we have a number being added or subtracted directly from the x. Now, what is the value of c in this case? Again, this is where the model is so critical. There is a built-in minus sign here. We'll see why a little bit later. And so c is the number that is being subtracted from the x. Well, in my example, that number is pi over 2. My value of c is pi over 2. Now let's go to the calculator. So just as before, I want to start out with the basic sine graph. I'll go to the z-trig option. And I do want to remind you how the z-trig window works. On the x-axis, we're counting here by pi over 2's. So pi over 2, pi, 3 pi over 2, 2 pi. It takes 4 of these spaces together to make 2 pi, the period of this function. Let's add in our second function, y equals sine of x minus pi over 2. Put those parentheses in the right place. And then let's add that to the graph and see what happens. The red function is the new function, and it looks very similar to the blue graph. In fact, it has the exact same shape. It looks like somebody just picked up the blue graph and moved it over slightly to the right. See this first hill on the regular sine function? Now the first hill is moved over a bit to the right. We call this a horizontal shift, or the language we're going to use is a phase shift. Now, how far did it move? Well, this point here is now here. It moved one tick mark over. In the z-trig window, this tick mark represents pi over 2. So this graph moved pi over 2 to the right. What about all of our other features? Well, I can see the midline is the same, the amplitude is the same. How about the period? Well, the beginning spot has been moved over a bit for the sine function, but if I count how many spaces it takes until it starts repeating again, I still get a distance of 4 total spaces, which we know in this graph represents 2 pi. So all of those other features are unchanged. Again, we had a horizontal shift to the right in the amount of pi over 2. The way we will abbreviate that is by saying there's a phase shift of pi over 2. A positive value for the phase shift means it went to the right. Okay, let's take a look at this second example. Now the first question we should ask is, what is the value of c in this case? And here's where you have to be really careful, because of course it's tempting to say pi over 4, but that's incorrect. There's that built-in minus sitting there in the model. So the question is, how could it suddenly turn into a plus? And the answer is, the only way is if somebody put a negative number in for c. Then those two minuses would plus out and we'd get plus pi over 4. So the c value here is negative pi over 4. You can probably guess what's going to happen, but let's take a look on the calculator. Let's see, I'll keep the basic sine function and then I'll change this one to be sine x plus pi over 4. And then I'll add this to the graph. It's the one that'll come up in red. And when you analyze the picture, you can see that the blue graph has just been slightly shifted over to the left this time. How much? Well, I think I can tell that this initial starting point has basically moved halfway between where it was and the first tick mark. The first tick mark is negative pi over 2. Half of that, half of pi over 2, would be pi over 4. So this is negative pi over 4. Again, we're not surprised. We typed in sine x plus pi over 4. So we would say there's a horizontal shift to the left by pi over 4. Or you could say there's a phase shift of negative pi over 4. All those other features, amplitude, period, midline, none of those have changed. Remember, when we write phase shift equals negative pi over 4, the negative communicates the fact that the graph moved to the left. Okay, we have an easy summary here. C is the phase shift. The C number represents the horizontal shift. Specifically, if C is positive, the graph will shift to the right. And if C is negative, the graph will shift to the left. By the way, this is why we have the built-in minus sign in these models. It preserves the fact that a positive C goes with right and a negative C goes with left, which fits with our intuition. Maybe the last comment to make: C is the opposite of what you see. And I hope that little phrase can help you remember. When you're looking at this equation, you see a negative pi over 2, but the value of C is positive pi over 2. Same thing here. You see with your eyes a pi over 4, but the value of the capital C is negative pi over 4. C is the opposite of what you see. Thanks for watching.